In August of this year, there were 263 fires burning at once in California. During the second half of August, 1.42 million acres were burned. For reference, that's bigger than the state of Delaware. During the normal wildfire season for California, 3 times less acres are burned than what was burned in 9 days this year. 2 fires in particular, the LNU and SCU lightning complex fires, burned a grand total of 750,000 acres combined. Either of these fires would have been devastating on their own in a normal year, but with hundreds of other fires burning in California at the same time, as well as firefighters having to compete with these 2 fires located in close proximity, it was a huge challenge. This year was particularly bad for wildfires. This was mostly due to a dry lightning storm near the SF Bay area. In 3 days, we had close to 11,000 strikes. With the combination of hot temperatures raised from previous years due to climate change, California being in a bad 2-year drought, and higher humidity which helped to produce the lightning storm, also from climate change, these fires have become more destructive than they used to be. Despite how purely bad forest fires sound, they do have some benefits to them. They deposit minerals into the soil, clear the forest floor of debris, clear out shrubs and bushes, which replenishes the water supply for different plants and animals, open the forest up to sunlight, kill diseases and harmful insects, and nourish some plant species that depend on fire to grow or distribute their seeds. However, these benefits come at the consequences of loss of property and life, pollution of air and water, as well as increased carbon dioxide in the atmosphere and eroded soil. Fire requires 3 things to burn: oxygen, a fuel source, and heat. When heat meets oxygen and a fuel source, like a lightning strike hitting a tree, it causes the chemical reaction called combustion, a more scientific word for burning. For an example of combustion, we'll use cellulose. Cellulose is an organic compound found plentifully in plant cell walls and wood. C6H10O5, aka cellulose, plus 6 oxygen equals 6 carbon dioxide plus 6 water plus heat. As you can see, this equation proves conservation of mass by showing that all of the reactants, meaning the substances that went through a change to get the products, what we're left with after the chemical reaction, have the same elements as the products. Simply put, mass isn't created nor destroyed in combustion. We can even calculate the heat released in combustion with the equation Q equals M times delta T times Cp, where Q equals the heat released in joules, M equals the mass of the substance in grams, delta T equals the change in temperature in Celsius, and Cp equals the specific heat of the substance in joules/grams Celsius. To demonstrate this, we'll be using water as our substance. We'll have 700 grams of water, an initial temperature of 27 Celsius, a final temperature of 50 Celsius, and the specific heat of water, which is 4.184 joules/grams Celsius. First, we need to plug in our values, then solve. After solving, we can then simplify it into significant figures. We do this by finding which of the values we plugged in has the least amount of significant figures. For this, that would mean we can change our heat release value into scientific notation with just 2 significant figures, since our change in temperature only has 2 significant figures. So we get 6.7 times 10 to the power 4 joules as our final answer. In conclusion, wildfires, the bright, hot, and glowing natural disasters we see a lot of in California, are harmful, but also very necessary and beneficial to the environment. Due to climate change raising temperatures year-round, a brutal 2-year drought, and higher humidity which set the stage for dry lightning storms, wildfires in California are becoming more and more common and more destructive.